Hi all, welcome to our practice e-learning day. This is the document that's attached on the It's Learning page. You can either print this off at home or not. You can do all your work on a scrap piece of paper and just use this as a reference on the computer screen. Since we're actually at school today, I have copies for everyone, so you can feel free to come up and get one to use. So you'll go through this classwork like we normally do. You can message me on It's Learning with questions. I wanted to give you a couple of, I guess, hints if you're stuck on this. This is really a review problem. It's at the end of Chapter 6, but really you have all the skills to do it right now. It's about getting to know your triangle. We're wanting to find all of the measurements of a triangle, which means I need to be able to find all three side lengths. I need to be able to find all three angle measures. So they have an example here where they give you vertices that you could put on a coordinate grid. So sometimes this is referred to as coordinate geometry. And last year I remember some people being stuck, not quite sure how to start. How do I find sides if I have ordered pairs? How do I find angle measures if I have ordered pairs? So I have an example. Here is 3 random ordered pairs, and I want to find the side length. So let me just think through, how would I find one of these side lengths? Let's do this side length here. If I'm looking for that one, in my head what I'm really doing is envisioning a right triangle. Do you see it? There it is. And I need to find the hypotenuse. So I would find this leg, which comes from taking this x value and subtracting the other x value. So 8 minus 2 gives me 6. I need to find the other leg, which takes this y value and subtract that y value, and I get 2. And then I can square my legs and then do the square root to find the hypotenuse, and boom, I have the side of the triangle. It also brings up the fact that there is a distance formula, and it comes from using the Pythagorean theorem with coordinate geometry. So if I didn't call this 8 and 4, but instead I called it x subscript 2 and y subscript 2, it's kind of tiny. Can you see it? Let me zoom in. There we go. And if I called this coordinate x subscript 1, y subscript 1. Remember, for me to find that 6, I said I was subtracting those x values. So for me to get one of the legs of the triangle, I have to take the x value, so I'm going to say x2, subtract x1 from it. And I know in the Pythagorean theorem, I square the leg, so that'll eventually get squared. Plus the other leg is subtracting the y value, so y2 minus y1 squared, and that equals c squared. But I don't want that side length squared, and I'm not going to call it c, I'm going to call it d for distance, because that's what I'm looking for. So I take the square root of both sides. And if you look up distance formula online, that's what you'll find. And since these get squared, this quantity gets squared, it doesn't matter if you do x2 minus x1 or x1 minus x2, because the only difference there is it could be 5, or if you do it the other way around, it's negative 5, and if you square both those numbers, the result is the same. So I can use the Pythagorean theorem, or I could use what we've developed now, the distance formula, to find all 3 side lengths of the triangle. So let's say, okay, I found all 3 side lengths of the triangle from, this paper. Right? Although they're not so nice, so I'm not certain you're going to get nice answers, but we've worked with things that are not pretty before. So now that you have all the sides, how do you go about finding any of the angles? So I'm going to think about, well, what tools do I have? Pythagorean theorem doesn't find an angle. Trigonometry, inverse trig helps me find an angle. I've got law of sines, law of cosines, similar figures. I don't even have 2 figures, I only have 1. So I'm thinking I'm going to go with one of my laws, either law of sines or law of cosines. To use the law of sines, I have to have a complete pair of an angle with its opposite side. I don't have that, so I'm going to go with the law of cosines. So let's say I want to find this angle first. The law of cosines would say that the side opposite to that, squared, I actually know that side. It's 7. So 7 squared is equal to the other leg squared, 3 squared plus 4 squared. It is minus, right? Where's my toolkit? Yeah, minus 2 times 3 times 4 times the cosine of angle C. Now the only variable here is my angle measure, so I can solve this using inverse trig. So I have 49 equals 9 plus 16 minus 24 cosine of C. 49 equals 25 minus 24 cosine C. Subtract 25. Why is that so hard? 24 equals negative 24 cosine of angle C. Divide by negative 24. And now I have -1 is equal to the cosine of angle C. I'm going to do inverse trig. And let's see what that gives me. So if I type that in and hit enter, 180 degrees? That doesn't make sense. Well, I don't really see my mistake, so my only guess is that, oh, I see exactly where my mistake is. Is this a possible triangle? The one that I just randomly made up? No, because the two shortest sides don't add up to be longer than the longest side. So the only reason my answer doesn't make sense is because I picked numbers that are physically impossible in a triangle. But you can follow this process to complete the rest of it. And I think that's all the hints you need to complete your classwork for today. There's plenty of grid space on the back if you want to approach it this way. Best of luck.